Hello everyone, I am Diana Rose Estvoro, and in this Activity 7 performance test, I am going to discuss the different fiber terms. My topics came from my name, which is D.R.F. So I'm going to discuss the dark fiber, semiconductor laser, and free space optics. First, let's start with dark fiber. Dark fiber is literally a lightless fiber optic connection without the activating equipment that is needed to send and receive data. The fiber optic cable remains dark. Dense wavelength diffusion multiplexing has been a huge factor in the development and improvement of dark fiber. Dark fiber is set up in several different ways. Two main configurations are popular, and those are point-to-point and multi-point configurations. Dark fiber makes it possible to establish a different connection between two locations. For example, between two branches of an organization, two data centers, or between a data center and an office building. This is the location A and location B, and it has a direct connection. Advantages of dark fiber. It has an unlimited bandwidth. This results in fast transmission of data and optimal connectivity for the users. The scalability. You can scale up based on your own connectivity needs. So if you want to assign extra bandwidth to a service or add extra services to the network, you can do so in a very short space of time. You do not need to buy any additional bandwidth to do this. Full control. You make your own strategic choices about how you set up, manage, and secure the network. Not only do you retain full control over how you manage and maintain the network, you also control project costs. Encryption. Both run through publicly accessible areas, which makes them vulnerable to physical thefts on the line. Has its own light generation equipment, you have greater control over connectivity security. And data centers. Dark fiber is used by a variety of organizations which require high-capacity network links. Application includes data centers, FTTA, SATCOM, and NREN. FTTA or fiber to the antenna. Mobile network providers can use dark fiber to use mobile backhaul, 5G backhaul, and core network connections. DCI or data center interconnect. Dark fiber can be used to provide a high-capacity, direct point-to-point connection between two data centers. By taking control of the equipment between the data centers, you can manage and control the link as if it's just an extension of your data center network. NREN, or National Research and Educational Networks. It links together universities and research establishments by dark fiber. In today's world, dark fiber can and will help people figure out when and where earthquakes will occur, hopefully warning people ahead of time so they can get as safe as possible. And of course, dark fiber can be used for business purposes too. With more and more research, new uses of dark fiber are being discovered, including nuclear explosion monitoring, micro-earthquake characterization, and offshore submarine volcano detection. So next, let's proceed to the semiconductor laser. A semiconductor laser is a device that causes laser oscillation by flowing an electric current to the semiconductor. The mechanism of light emission is the same as the light-emitting diode. As you can see here, the light is generated by flowing the forward current to a p-n junction. In forward bias operation, the p-type layer is connected with a positive terminal and the N-type layer is connected with the negative terminal. Electrons enter from the N-type layer and the holes from the P-type layer. When the two meet at a junction, an electron drops into a hole and light is emitted at the time. These are the types of semiconductor laser. The Fabry-Perot semiconductor laser, DFB semiconductor laser, and FBG wavelength stabilized semiconductor laser. Fabry-Perot semiconductor laser. It is characterized by the use of the cleavage plane of a laser crystal for reflection of the light emitted in the active layer. Since Fabry-Perot LD has no mechanism to select a specific oscillation wavelength, the multiple laser oscillation occurs within the gain bandwidth. The oscillation of the multiple wavelengths causes pulse broadening in an optical fiber transmission, and therefore it cannot be applied for a long-distance communication. The DFB semiconductor laser has a grating below or above the active layer and oscillates at a single wavelength defined by the Bragg wavelength of the grating. This exhibits superior performances, including a narrow spectrum width and low noise, and hence is used as an optical signal source in a long-haul optical communication. FBG wavelength stabilized semiconductor laser has an excellent performance like a single wavelength oscillation. It is expensive for manufacturing difficulty. In this case, the laser cavity is composed of the HR-coated end face of the active layer and the low reflection FBG. The other end face of the active layer and the incident end of the fiber have AR coating to prevent reflecting light. In addition, the incidence end of the fiber is processed to a lens configuration to collect the light. Since the FBG formed in the fiber core only reflects a specific wavelength, a single wavelength oscillation occurs. This is the semiconductor laser application. The functions are read, features high-speed rating of ultrafine signals with micro spot. Examples are reading of optical discs like CD, DVD, or BD. Record uses high output to change the color of an organic film or phase of a crystal to write a signal. Examples are recording on optical discs like CD, DVD, or BD. Sensitivity draws signal by irradiating a photosensitive drum. Examples like lasers, printers, MFC, etc. Communication supports high-speed modulation for transmitting large amounts of information. Examples are optical communication in PCs, mobile phones, and more. Lighting. Beam spot irradiation enables accurate pointing. Examples are laser microscopes, pointing makers, line lasers. Measurement. Less distance attenuation, extending reach. Measure distances of roads and between cars, building heights. Sensing. Easy to create fringe pattern to detect slight changes. Examples are sensing applications including smoke alarms, dust management, and laser mice. Advantages of semiconductor laser. It has smaller size and appearance. It is economical. The construction is very simple. No need of mirrors. It has high efficiency. Low power consumption. Disadvantages of semiconductor laser. Due to relatively low power production, these lasers are not suited to many typical lasers applications. Semiconductor laser is greatly dependent on temperature. The temperature affects greatly the output of the laser. The lacing medium of a semiconductor laser is too short and rectangular, so the output beam profile has an unusual shape. Beam divergence is much greater from 125 to 400 milliradians as compared to all other lasers. The cooling system requirement in some cases may be considered its disadvantage. So let's proceed to free-spaced optics. Free-spaced optics, or FSO, is an optical communication technology in which data is transmitted by propagation of light in free space, allowing optical connectivity. FSO system consists of an optical transceiver at both ends to provide full duplex bidirectional capability. These are some examples of FSO all over the world. How does FSO works? First, network traffic converted into pulses of invisible light representing ones and zeros. Next, the transmitter projects the carefully aimed light pulses into the air. Then, a receiver at the other end of the link collects the light using lenses and/or mirrors. Then the received signal converted back into fiber or copper and connected into the network. And then, reverse direction data transferred to the same way, full duplex. Anything that can be done in fiber can be done with FSO. This is the challenges FSO may encounter. Fog. Fog substantially attenuates visible radiation. Optical beam of light is absorbed, scattered, and reflected by the hindrance caused by fog. Scattering caused by fog is largely a matter of boosting the transmitted power. The low clouds. It can completely block the fraction of optical beam transmitted from Earth to the space. The attenuation caused by the clouds is difficult to calculate because of the diversity and inhomogeneity of the cloud particles. The scintillation. Fluctuations in signal strength can be caused by variations in temperature of air packets between the transmitter and receiver due to natural differences or objects such as buildings. This effect, known as refractive turbulence, causes image dancing or blurring of the signal at the receiver end, which results in amplitude loss. Then, the building motion. Building sway due to the wind can be a problem as it disrupts the alignment between the two transceiver units, causing loss of signal. Divergent beam technology can be used to allow the units to communicate in this situation, but performance is still slightly affected. Each of these factors can attenuate or reduce the signal. Advantages of FSO. Free space optic solutions offer various advantages of normal RF signal wireless networks, such as free space optics does not suffer from radio frequency interference or band saturation, license-free operation, no software needed on client devices, very high security level operation. FSO is certified in governmental and defense applications for transferring confidential and classified information. Inside installation is possible and it affected by operation through glass. Typical free space optics application. Free space optics wireless networks can only operate as point-to-point links between two units. However, when combined with LAN or WLAN networks, they can provide very effective solution to many scenarios, such as provide a bridge between WLAN to WLAN connections on campuses at fast Ethernet or Gigabit Ethernet speeds to cater for many subscribers, provide a bridge between LAN to LAN connections in a city between enterprise buildings that need to have reliable, high-throughput networks. Create a wireless link across an area in which you do not have physical access. Fast service delivery of high-speed access to optical fiber core networks. Service provider backhaul to carry large amount of data between the client network areas and the core network. Converge voice data connections. Temporary WLAN network setup and installation for events such as conferences. FSO can be installed in redundancy systems to provide fallback fail-safes for critical operations that require network access. So that's all for today. Thank you and have a blessed day.